Hello once again and welcome to lesson number 10. In this lesson, I want us to design a runtime meter for a machine, recording seconds, minutes, and hours of the machine while it's running. Okay, we can assume we have a simple pump having a start and stop push button. Okay, so in the previous lesson, we spoke about the clock memory byte. We're going to be utilizing the clock memory byte, and then we're going to be learning how to use move instructions. We're going to also be learning how to use let's create a new function. You're going to also be learning how to use math functions. Let's call this machine. Let's say match run time, machine run time, something like that. Okay, go ahead and create a project, machine run time. Okay, so you will be learning how to use the clock memory byte, how to use the move instruction, how to use the math function, and also we'll be learning how to use the comparison instruction. Okay, let's go ahead and add the new device. Before I waste your time, let's go ahead and add the CPU 300 PLC. Let's choose, say, this one. Let's choose the second one. Go ahead and add the hardware onto the project. So we will be recording the machine's runtime, recording seconds, minutes, and hours. Okay, so our task is to record the seconds, minutes, and hours of the machine. It's just a basic runtime meter that we're going to design here using the adder and the clock pulse. Okay, so this is what we're going to be doing. I want us to save the project and go ahead and go into properties. So you click on the PLC itself, and then you can actually right click if you want and go to properties of the PLC. Okay. Now we want to actually look into the clock memory. We want to go and look into the clock memory. Okay. Now I want you to actually tick that box where now you enable the clock memory. It gives you memory byte 0, which tells me that my clock memory byte is 0. So the first bit will be M0.0 and the last bit will be M0.7, giving me how many? 8 bits of the clock memory byte. Okay, so once I've done that, I'm going to click here and also start the simulator so that I can actually load this onto the PLC, note the changes that have enabled the clock pulse, the clock memory byte for this particular PLC. Now this is my PLC, this is my CPU. Now I want to add this. Now I'm going to change this to PLC sim, and then I'm going to start search. You can see it's looking for that PLC, the connection between the PC and the simulator. I'm going to load the configuration onto the PLC. Okay. As you can see, it is loading. Okay, there are no errors, there are no warnings, as you can see there. Now we have also created and loaded the main OB1 successfully. Now I want us to actually go online with this PLC. Okay, we go there, and then you can see we've got MB0 for the clock memory byte 0 that was activated here. Okay, we can actually go to properties. You can see we've activated the clock memory byte 0. Now this is what we are actually checking on the PLC here. MP0 for clock memory byte 0, having how many bits? 1, 2, 3, 4, 5, 6, 7, 8 bits. Now let's see and observe what's going to happen if I turn the PLC to run mode. Let's put the PLC in run mode and see what's going to happen. Okay, see that? Look at this. Look at these bits here. These bits are actually flicking at a second. certain frequency. They are actually flicking at a certain, flashing at a certain frequency. But I'm interested in this frequency here at M0.5, at M0.5 here. Okay, which gives me 1 second period. That's what I'm interested in for now, but that's what I'm going to use in this particular project. Let's go ahead and put this into stop mode and minimize and go to program blocks and start programming. Okay, now we're gonna, before we start programming, I want us to edit the text. We go to a tag table, we go to tags, we add, or we can just rename this default tag table and call it pump, say runtime. Okay, we just do that. Then I'm gonna open the tag table and start putting in the addresses there. Okay, the first address will be start push button, because I'm gonna start the pump. Start, say pump. Okay, and then the default address there is I0.0, which is pull. The second one is going to be a stop push button, stop pump. Okay, there you go. The next one is going to be pump run, which is the output. Pump run, which is the output now. It's also pull, which is the output. I'm going to give it an address Q0.0 in this case. Okay. Then the next one will be, I want to indicate that the pump is running. This is going to be pump on. Okay. Then I'm going to give this an address, a marker address. I'm going to give it M, say M 20.0, something like that. Okay. This shows that the pump is running. Okay. This shows that the pump is running. You can use this on an HMI. Okay, if you want. And then what else? I want to actually have an integer value. I want to have an integer value. An integer value that will be stored at memory weight. I want to put it at memory weight. Let's use 40 in this case. It's fine. Memory weight 40. It's an integer. Then I'm going to call this seconds. Seconds. I'll be recording seconds here. The next one is going to be minutes, which is also an integer. Okay, this goes to memory weight 42, because memory weight 40 took 40 and also 41. So the next address will be memory weight 42. Okay, now the next one will be hours. Hours. Okay, and it's also an integer value, which goes to memory weight 44. I'm going to save this and I'm going to start programming. Okay, I'm going to close this window here, and then I'm going back to my MB main OB1. Okay, the first network will be start pump, or okay, start pump, something like that. Start a pump. Let me just put in simple English language. Start a pump. Okay. How do I start a pump? I need a stop push button, I need a start button, I need a coil. And also I can actually retain this if I want. And at the same time, I also want to indicate that the pump is running. I can do that, that's not a problem. Now this is my stop push button. I hope I'm not rushing too much. This is my start push button. That is my pump run. This is also pump run. Where's my pump run? There you go. This is pump on. This is an indicator lamp that will be displayed on an HMI. If you've got an HMI, we're still going to do HMI design and visualization. Okay, we're still going to program the HMIs. So our lessons will go up to 50, lesson number 50 or lesson number 100. It doesn't matter. As long as you've got time to do so, we do that. Okay. Then next, okay, before we go to the next network, so this network here, we can start the pump, and then it's gonna come on, retain itself, and then it's gonna indicate there. We can also stop the pump here. Okay, this should be fine. Happy? Okay. The next network now. On this network, I want us to now start recording the seconds. Let's put seconds there. Okay, here we can actually utilize that clock memory byte. Okay, let's utilize the clock memory byte. We go to bit logic instructions. We take a normal open contact there. We give it an address M0.5, which gives us 1 second. Okay, I'm gonna rename that, and I'm gonna say give it 1 hertz. Happy? Which gives me 1 second. I know it's give me 1 second. I know that. Okay. So based on the clock memory byte from the previous lesson. So if you didn't watch that video, you need to go to lesson number 9. Then you learn a lot about the clock memory byte, about the frequencies there and the allocation. Okay. Then you understand better. Okay. So this will be flashing at 1 second. Ta, 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 ta. Comes on and off, on, off, on, off, on, off. Okay, the period is 1 second. Now, this is what I want to do. I want to use this information here that the pump is running. So I'm going to take a normal open there. The pump is on. Can use that. The pump is on. Then I'm gonna, this flicking here, if the pump is on while this is flashing, is gonna record. This is gonna be giving me a 1. Then that 1, it comes on once. I'm gonna take the information, I'm gonna take an adder. I'm gonna take an adder instruction under math functions. Okay. Then I'm gonna change this to an integer. So I'm adding 2 integers. I'm adding a 1, 2, a memory area that is seconds. Then I'm going to store that again into seconds. Okay, so this is what's going to happen here. While this gives me 1 second, while the pump is on, 1 will be added to a 0. Initially, there will be a 0 there. So it is 1 plus a 0, which gives me a 1. Then the sum will be stored again in memory word 40. Remember, it's an integer, so it's a 16-bit or it's a weight in any case. Okay, memory word 40, which is an integer. Okay, I hope you guys understand. So the data type there is integer, which takes 16 bits. Okay, it's a weight, 100%. Let's go. Now, let us have a look into this before we go ahead. As it is now, look at this instruction here. This thing won't work. Okay, I'm going to show you why. As it is now, it won't work. Yes, it will do an addition, but it will be adding, say, a value in hundreds, not 1 plus a 0, but it will do the cycling. The minimum cycle time is actually 1 millisecond. So it's going to do that how many times in 1 second? Okay, before I talk a lot, let me demonstrate what I'm talking about. Okay, so let's go ahead and download the first 2 instructions onto the device. Okay, let's do that and see what's going to happen. Okay, so now I'm downloading this onto the CPU. It's now downloaded, and I want to actually go and monitor my tech table. Let me go and monitor the tech table. So I just want to monitor the seconds. I want to monitor the seconds. See where I'm clicking. I'm monitoring the seconds. Leave the others. Then I'm going to go ahead and click on the menu classes because I want to monitor those seconds to see the change in seconds. Look at seconds there. See, the value is 0. I'm going to go ahead and start the pump. You can see start pump is false, stop pump is false, run pump is false, pump on is false. Okay, I'm going to go to my simulator. Let me drag and drop it here. Then I'm going to start the pump. Okay, before I start the pump, I want to put this in run mode. Can you see that? Look at that clock pulse there, at that memory bit there, M0.5 in 1 hertz is flicking. See that? Comes on, off, on, off, on, off, on, off. Can you see that? Look here, it goes on, off, on, off, on, off. So I'm utilizing that function, and then I want to start a pump. And then when that happens, I want that function, that adder function, to actually add a 1 onto memory word 40. Let's see what's going to happen. Let's go ahead and start the pump. Look at that, look at that, look at that value. It goes, it's sitting at 145, 242. See, it's adding so many times in 1 second. So it's not what we want, because we want to add seconds, not hundreds seconds. So it's actually doing this how many times in 1 second? 100 times, 1,000 times. Now look at that, look into that. We don't want that. Okay, now how do you prevent this from happening? Okay, let me go ahead and actually stop this from running. Look at that value. It was sitting at 1562 currently. Let me stop the CPU. Okay, see that? Okay, so how do we prevent this from happening? How do you do that? Let me go ahead and minimize this. Now let's go on to the software. You can actually minimize this by going to BitLogic operations and pulling up a positive trigger and put it here. Okay. This is going to make sure that it looks at one transition between when this changes from 0 to 1. Okay. 0 to 1 is going to add a 1 once, which gives us 1 second. Okay. All right. So it needs an address there. I'm going to give it an address, say M, say 30.0. Let me just do that. Okay. All right. 100%. And then I want to actually go ahead and test this now. Let us, but it should work. I don't want to test it now. Okay. Let's go ahead and do hours. What's going to happen now, when it goes on and off, is going to take one transition, looking at one change. When it changes from 0 to 1, it's going to record 1 plus a 0, it gives me 1. Okay. And it's going to go back again into the same thing, which gives you 1 plus 1, which is 2, 2 plus 1, which is 3, 3 plus 1, which is 4, and you go on and on and on and on up until 60 seconds, which gives me how much? 1 minute. 1 minute, 2 minutes, 3 minutes, up to 60 minutes, which gives me 1 hour. That's what we are doing. Okay. So I want to go ahead and use that information now to say, if this value here, memory word 40, is now 60 seconds, that should give me 1 minute. So I can take a comparison instruction, go to comparator operations, you go to comparator operations, you go to this instruction here, you drag it and drop it here. Okay, and I'm going to change this to, so this is going to say if this value, which is memory word 40, which is seconds, where's my seconds? Which is seconds. If this value is equals to, say, 60, in this case, if this value is equal to 60, I want this to actually, while the pump is on, don't forget that while the pump is, I can copy this, while the pump is on, I can do this. I want this again to add a value. So there's another adder. I go to math operations, I take an adder, I drag and drop it here. So I want this again to add 1 to now another address, which is minutes. Okay, I want this to add a 1 into that value, and it's an integer too. Then that must also be stored in the same address, which is minutes. Okay, are you with me? Okay, hope you guys are following. So if 1 plus a 0 is 1, this value is going to be 1, that value is going to be 1, which is now less than a 60. So this won't come on it. This function won't be 1 plus a 0 because the comparison there is not 60 as yet. But as soon as this comparison is 60, then this addition will take place. This operation, this function will come into operation. This function here, when these two values are equal. When memory word 40, which will be 60, equals to 60, then the adder function will come into operation saying 1 plus a 0, which is 1, gives me 1 minutes in this case. Okay, so you can go ahead and say here, this is minutes. Okay, I'm recording minutes there. But as it is now, again, it's going to give us the same problem that we had earlier on network 2. How do I prevent that? Again, I use a positive trigger. Let me just go, so that I can show you. I go again, and to bit logic operations, I take a positive trigger. I can drag it and drop it here. I'm going to give it a different address, which is now M30.1 in this case. Okay. All right. So this is going to prevent that from adding a value again and again in one scan. Okay. I'm going to prevent that again by using the same positive trigger. Okay. Now that I've got 1, because after when this memory word 40 is 60 seconds, I'm going to be having 1 minute there. Okay. But now that I've got 1 minute, I need to get 60 minutes for 1 hour. Do you agree? Okay, so I need to again have the comparison instruction. I go back to comparator operations. I take another comparator, I put it there. Because I want to compare what now? I want to compare minutes now. I go to minutes, which is memory word 42. And then I'm going to compare it with, again, 60. Are you with me? Okay. So if these two values are equal, execute the next instruction. I also take the positive trigger. I take the, and then I give the different address again, which is say memory word 30 point, what's that? 2, the next one. Okay. Then again, while the pump is on, I cut this, copy this and paste it here, not cut, copy and paste it here. While the pump is on, you can do the addition. You go to math instruction, you can still do the addition there. Are you guys with me? Okay, again, I'm going to give it an address. You add a 1 onto hours now, onto hours. Okay, onto hours. Again, you give the same address there. The output is hours, which is memory word 44. Okay, hope you guys are following. So here's what's going to happen. Let's start here. If the pump is on, this bit is going to come on. This normal open, go to normally closed. While this is flicking, this is going to see a change from 0 to 1 transition. It's going to add a 1 into a 0, that becomes 1. Up until this goes to 60. When 60 is equal to 60, again, this is going to add a 1 here, which gives me 1 minute. Then I'm going to be having 1 minute here. It goes up and up and up until 60. When that is equal to 60, I'm going to be having 1 hours now. Okay, which is 1 plus 0, which is 1 hour. This will go on and on and on and on up until how many hours, depending on the running hours of the machine now. Okay. Are you happy? Hope you guys are following this. Now, I want to make sure that I don't keep on recording those seconds. I need to reset The seconds, okay, I need to reset these seconds. When do I do that? Okay, as soon as this value here, see this value here, as soon as this goes to 60, this memory word, this M30.1, okay, it's gonna go high. When it goes high, I can use that information to reset that adder. As soon as it goes to 60, this comes on. This becomes true. When memory word 40 is equals to 60, this bit comes true. When it comes true, then the addition takes place where I'm having 1 minute. Now I need to reset this to 0. I need to reset these seconds to 0. Are you with me? So I can use the move instruction. How do I do that? So I'm using this information that I'm using this. I know that if this bit comes on, which bit? Let me go up a little bit. As soon as this is equals to 60, this bit comes on. When this bit comes on, then the addition takes place. But I need to reset this to 0 such that it doesn't go to 61, 62, 63. I don't want that. I want it to stop at 60. Are you with me? Now I can reset that. I can just type in reset. Wait, man. Reset seconds. Okay. Then I can go ahead and type in, say, memory marker 30.1. Okay. Are you with me? That is when these seconds are equals to 60. I want to reset using this bit because I know that this will come on immediately when that happens. Now I'm using that information that when this comes on, now reset the counter, reset the addition, reset that value to 0. Now I use the move instruction, the move operation. This is like load and transfer, okay. Now I'm moving a 0, to seconds, to memory word 40. Okay, memory word 40, that's what I'm doing. Hope you guys are following. And again, I need to make sure that when this value here, in minutes, when it goes to 60, it mustn't go to 61, 62, 63. I need to also reset minutes. Okay, I would love to do that. Okay. I'm also using this, not the same instruction, but now when is that happening? That happens when M30.2 comes on. Okay, when M30.2 comes on, when minutes are equals to 60, when memory word 42 is equals to 60, this bit will come on, will become true, then the addition will come on, will become true, where now we've got 1 hour, which is 1 plus a 0, which gives me 1 hours. Okay, 1 hour. Now that will be memory marker 30.2. Okay, are you guys happy? Then I also want to move. Now I go to move operations. I want to move a 0. This is resetting minutes. Okay, memory word 42. Are you guys following? Okay, memory word 42. Okay, now you can go ahead, go back and recap. When the pump is on, start the pump, you can stop the pump, start the pump is on. If the pump is on, this bit will come on, then the addition will 1 plus a 0 when that goes flashing. Then this will be 1 plus a 0, then it stores that. If it goes to 60, this bit comes on, making sure that the addition takes place. Then we're going to have 1 minute. Okay. If this happens again, goes back to seed, we're going to have 2 minutes, 3 minutes, 4 minutes, up until 60 minutes. Then this will be equal. When that happens, we're going to be having 1 hours. Okay, hope you guys are fine. Now that I've resetted, let me type in on network 6 with a reset minutes. Reset minutes. Okay. All right. Okay. I can also design, let's say for maintenance purposes, if I want to maintain the pump, let's say I want to maintain the pump, I will want to reset using the one reset button. I would love to reset all the adders, resetting seconds, minutes, and hours. It would be nice to do so. Okay. Now I can use that stop push button if I want. Are you with me? I can use, in fact, this stop push button comes in handy. This can actually do the same job. Okay. But let us design that particular set so you guys can understand what I'm talking about. Okay. I can go ahead and say, I need a normally open contact. Let me give it a different address and say I 0.3. Then I'm gonna rename that to let's give it reset all. Reset underscore all. Something like that. Change. Excuse me, this reset all. Now, how do I reset all? I can take the 3 move instructions. I can copy this, paste it here, paste it here. Okay, to say move a 0 to memory weight to seconds. Also move a 0 to minutes. When that happens, move a 0 to hours. Are you guys with me? Just rearrange that. Now, when I press the reset button, a 0 will be moved to memory weight 40, a 0 will be moved to memory weight 42, a 0 will be moved to memory weight 44, resetting seconds, minutes, and hours. Okay. But again, this does exactly the same thing, if I may say so. Okay. Now, I want us to load this onto the CPU. This is our CPU. Okay, there is our simulator. I want us to load this onto the CPU, download this onto the PLC, and then I want us to monitor seconds, minutes, and hours. Okay. It's going to take us at least an hour, maybe and more than an hour, because I need to pause the video while it's still running. Okay. Now this is what I'm going to do. I want us to go ahead onto the table of hours. See under text here. Under text here, you open that envelope. Then you open up the tech table there. And then I want us to actually download this program onto, where's my main? Let me open my main. I want us to download this program, all these changes onto the CPU. Let's download all these changes onto a CPU. Okay. All right. Let's download all these changes onto the CPU. Yes, let's do that. Okay, it's been loaded. Now that we've done that, I want us now to monitor. We can monitor this. We can take the CPU to run mode. This is our CPU. You can take this to run mode. See what's happening. See, it's going true, false, true, false, true, false, but it's not actually helping us anyway because the pump is not on. Now I want us to go to the pump runtime and actually start the pump. Okay, where's my, let's start the pump. The pump is on. As you can see, the pump is on, and the seconds is 5 seconds, 6 seconds. As you can see, 7 seconds. Look at the seconds there. Look at those seconds there. 10 seconds. See this row here. You see it's 16 seconds now. Looking at this row. 20 seconds, 21 seconds, 22, 24, 25, 26, 27, 28, 29, 30. When it goes to 60, it's going to give us 1 minute. Okay. So now you guys have learned how to use the clock memory byte. You've learned how to use the move instruction. You've learned how to use the math function, just one math function where we were using the adder. Okay, this is just a basic runtime meter. There are other runtime meters that are available in the Siemens Step 7 software that can be used. Okay, the SFCs, we can just drag and drop that and use it. Okay, but I just wanted to design it so that we can learn more about how to write a simple basic PLC program. I hope you guys are learning. You can see now we are sitting at 1 minute. Okay, look into that. We are now sitting at 1 minute. We are going again on 2 hours, second minute. But what I'm gonna do, I'm gonna pause this video while the PLC is running. Maybe after 30 or 45 minutes, I'm gonna come back and check exactly where are we with our runtime meter. This, when it goes to 60, it must reset to 0. Let's check that when it does that. 58, 59, 0. See, it goes again back to 0. This also must reset to 0. Okay, when it goes to 60 again. But hours must, I want to see those hours. You can go up to 24 hours or more than 24 hours, doesn't matter. Okay, as long as the pump is still running. Okay, because the pump is running, the pump is on. That is why we've got seconds and minutes. We've got 0 hours for now. Okay, I hope you guys are following what's happening. Now I want us to pause this video. Then we're going to come back and check where our runtime meter is. Okay, we're going to check it maybe at let me set my alarm. I'm going to check it at say 1 o'clock or 10 past 1. Okay, happiness.